Hey guys, tonight we begin with a question that has haunted humanity since we first looked up at the stars. A question so vast, so mind-bending, that even our most brilliant scientists struggle to wrap their heads around the answer. How big is the universe, really? And I mean, really, not the sanitized version you learned in school, but the raw, terrifying, beautiful truth that will make you question everything you thought you knew about existence itself. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Picture this. You're standing in your backyard on a clear night, looking up at the stars. You see thousands of them, scattered across the darkness like diamonds on black velvet. It's beautiful, it's peaceful, and it's a complete lie. Because what you're actually looking at is so incomprehensibly massive, so brutally infinite, that your brain literally cannot process it. Those stars you see, they're not even a rounding error compared to what's really out there. They're less than a grain of sand on an endless beach that stretches beyond the horizon of your imagination. Tonight, I'm going to take you on a journey that will fundamentally change how you see reality. We're going to start small, with distances you can understand, and then we're going to scale up, step by step, layer by layer, until we reach numbers so large they stop having meaning, until we encounter concepts that make infinity look quaint. And by the time we're done, you'll understand why some of the world's most brilliant minds have gone mad trying to comprehend the true size of everything that exists. But here's what makes this even more unsettling. Everything I'm about to tell you is conservative. The real universe, the one that exists beyond our ability to observe it, is almost certainly larger, possibly infinitely larger, and that possibility that we live in a cosmos with no end, no boundary, no edge, should terrify and inspire you in equal measure. Let's start with something familiar, something your mind can actually grasp. The distance from your house to the grocery store. Maybe it's a mile. Maybe it's 5 miles. You can drive it, you can walk it if you're feeling ambitious. Your brain understands this distance because you've experienced it. You know how long it takes. You know what it feels like. This is human scale distance, and it's comfortable. Now let's take our first step into the unknown. The distance from Earth to the Moon is about 240,000 miles. That sounds like a lot, but it's still somewhat graspable. If you could drive to the moon at highway speeds, it would take you about 5 months of non-stop driving. Uncomfortable, sure, but your mind can still wrap around it. You could imagine making that journey, even if you'd never actually attempt it. But here's where things start to get weird. The sun is about 93 million miles away from Earth. Suddenly, our moon distance looks pathetic. If you tried to drive to the sun, it would take you over 100 years of continuous driving. No stops, no sleep. Just you, pedal to the metal, for longer than most people live. And that's just our local star. The one that makes life on Earth possible. The one that's practically next door in cosmic terms. Let me give you another way to think about this distance. Light, the fastest thing in the universe, takes 8 minutes to travel from the sun to Earth. 8 minutes. That means when you look at the sun, you're not seeing it as it is right now. You're seeing it as it was 8 minutes ago. The sun could explode this very second, and you wouldn't know for 8 minutes. This is your first taste of how space and time become twisted at cosmic scales. Now, let's leave our solar system entirely. The nearest star to our sun is called Proxima Centauri. It's 4.2 light-years away. A light-year is the distance light travels in 1 year, which is about 6 trillion miles, so Proxima Centauri is roughly 25 trillion miles from us. If you tried to drive there at highway speeds, it would take you about 45 million years. That's longer than humans have existed. That's longer than most species survive. You could start the journey when the first human ancestors climbed down from the trees, and you still wouldn't be halfway there. But wait, it gets worse, much worse. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars, each one separated by distances that make our trip to Proxima Centauri look like a stroll to the mailbox. The Milky Way itself is about 100,000 light-years across. Light, remember, the fastest thing possible, takes 100,000 years to cross our galaxy. If you started at one edge and travelled at the speed of light, the entire rise and fall of human civilization would happen dozens of times before you reached the other side. And here's the thing that should keep you awake at night. Our galaxy isn't special. It's not particularly large. It's not particularly small. It's just average. There are galaxies out there that make the Milky Way look like a village compared to a megacity. IC 1101, for instance, is about 6 million light-years across. If our galaxy is a grain of sand, IC 1101 is a basketball. But even this massive galaxy is just one of trillions. The observable universe contains an estimated 2 trillion galaxies, each one containing billions or trillions of stars, each star potentially hosting planets, each planet a world unto itself. The numbers become so large they lose all meaning. It's like trying to count to infinity. Your brain simply gives up. The observable universe, the part we can actually see, is about 93 billion light-years across, not 13.8 billion, which is how old the universe is. 93 billion. This is because space itself has been expanding while light has been travelling toward us. The most distant objects we can see are now much farther away than they were when their light first began its journey to us. But here's where things get truly mind-bending. The observable universe might be just a tiny fraction of the actual universe. We can only see as far as light has had time to travel since the Big Bang. Beyond that, there's more universe, possibly much more, possibly infinitely more. We just can't see it because the light hasn't had time to reach us yet. Think about this for a moment. Right now, at this very second, there are galaxies so far away that their light will never reach us. The expansion of space is carrying them away faster than their light can travel toward us. They exist, but they are forever beyond our ability to observe. They are real, but they might as well be in another reality entirely. Some cosmologists believe the universe is infinite, not just really big, not just bigger than we can measure, infinite, with no edge, no boundary, no end. If this is true, then everything that can exist does exist. Somewhere out there, in the infinite expanse, there's another Earth, another you, another version of this exact moment playing out with slight variations. In fact, there would be infinite versions of you living infinite variations of your life. This is the multiverse hypothesis, and it's not science fiction. It's a serious scientific possibility based on our best understanding of cosmic inflation and quantum mechanics. If the universe is infinite, then probability demands that every possible arrangement of matter must occur somewhere, including exact duplicates of you, reading these exact words, having these exact thoughts. But even infinity might not be the end of the story. Some theories suggest our universe is just one bubble in an infinite foam of universes, each bubble a complete cosmos with its own laws of physics, its own version of reality. Some might be similar to ours, others might be so alien that matter as we know it cannot exist. In some, time might run backward. In others, there might be 11 dimensions instead of the 4 we experience. This is where human language breaks down entirely. We don't have words for concepts this vast. We don't have analogies that work. It's like trying to explain color to someone who was born blind, or music to someone who was born deaf. Our brains evolved to understand the scale of hunting grounds and tribal territories. They were never meant to grasp the infinite. And yet, here we are, standing on a small rock orbiting an average star in an unremarkable galaxy, somehow able to peer into the deepest mysteries of existence. We've built instruments that can see nearly to the edge of time itself. We've developed mathematics that can describe infinities within infinities. We've created theories that predict the existence of realities we can never directly observe. The ancient Greeks had a word, cosmos. It meant both the universe and beauty, order, harmony. They understood that the universe wasn't just vast, it was elegant. The same mathematical principles that govern the orbit of planets also describe the structure of atoms. The patterns we see in galaxies echo the patterns we see in the growth of plants. Everything is connected across scales we can barely imagine. But there's something else the Greeks understood that we often forget in our modern age. The cosmos is not just something we observe from the outside. We are part of it. Every atom in your body was forged in the nuclear furnace of a dying star. You are literally made of star stuff, as Carl Sagan famously said. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar explosions billions of years ago. This means that when you look up at the night sky, you're not just observing the universe. You're participating in it. You are the universe becoming aware of itself. You are a way for the cosmos to know itself. This isn't poetry or mysticism. This is literal fact. The atoms that make up your brain were scattered across space for billions of years before gravity and chemistry conspired to arrange them in just the right way to create consciousness, curiosity, wonder. And this brings us to perhaps the most profound question of all. In a universe this vast, this ancient, this full of possibilities, are we alone? The famous Fermi paradox asks, if the universe is so big and so old, where is everybody? With trillions of galaxies and countless potentially habitable planets, why haven't we encountered other intelligent life? The silence is deafening and terrifying. It suggests one of several possibilities, none of them particularly comforting. Maybe intelligent life is incredibly rare. Maybe we're among the first to evolve to this level. Maybe civilizations tend to destroy themselves before they can spread to the stars. Or maybe the universe is so vast that even with countless civilizations out there, the distances are simply too great for us to ever find each other. But there's another possibility that should make you pause. Maybe we're not looking in the right places or in the right ways. Maybe intelligence and consciousness can take forms so alien to our experience that we wouldn't recognize them even if we encountered them. Maybe the universe is teeming with life and intelligence, but it's operating on scales and timescales so different from ours that we're like mayflies trying to understand the life cycle of a redwood tree. Consider this. If there are civilizations millions of years older than ours, their technology would be so advanced as to be indistinguishable from magic. They might exist as pure energy or as quantum information or in dimensions we can't perceive. They might have transcended the need for planets and stars entirely, existing as patterns in the fabric of space and time itself. And this is just the beginning of our journey tonight. We've barely scratched the surface of how big the universe really is. We've talked about distances and numbers, but we haven't even begun to explore the stranger implications, the places where our understanding breaks down entirely, the regions where space and time themselves become meaningless concepts. We haven't discussed the cosmic web, the largest structure in the universe, made of dark matter and dark energy that we can barely detect, but which makes up 95% of everything that exists. We haven't explored the possibility that our three-dimensional reality is just a projection of information encoded on a two-dimensional surface, like a cosmic hologram. We haven't delved into the quantum realm, where particles can exist in multiple states simultaneously and where the act of observation changes reality itself. We haven't touched on the mind-bending reality of black holes, where gravity becomes so intense that it literally tears holes in the fabric of space and time. Places where a teaspoon of matter weighs as much as Mount Everest, where time slows to a crawl and eventually stops altogether from an outside observer's perspective. At the center of our own galaxy lurks a supermassive black hole called Sagittarius A star, containing the mass of 4 million suns compressed into a region smaller than our solar system. But even black holes pale in comparison to some of the structures we've discovered lurking in the cosmic deep. There are supervoids, regions of space so empty they make the vacuum between galaxies look crowded. The Boötes void, for instance, is a sphere of nearly empty space 330 million light-years across. If the Milky Way were located in the center of this void, we wouldn't have discovered other galaxies until the 1960s. Imagine how different our understanding of the universe would be if we lived in such cosmic isolation. Then there are the cosmic filaments, threads of dark matter and galaxies that stretch across billions of light-years, forming the largest structures in the observable universe. These filaments connect galaxy clusters like a vast cosmic web, with enormous voids between them. The scale is so immense that entire galaxy superclusters are reduced to mere decorations on these cosmic strings. And here's something that will make you question reality itself. The universe isn't just big in space, it's big in time. When we look at distant galaxies, we're not just seeing faraway places, we're seeing far back in time. The most distant galaxies we can observe appear as they were when the universe was less than 1 billion years old. We're literally looking into the cosmic past, seeing the universe when it was young and chaotic and very different from today. This creates a strange paradox. The farther we look into space, the further we look back in time. At the edge of our observable universe, we see the cosmic microwave background radiation, the afterglow of the Big Bang itself. This light has been traveling toward us for 13.8 billion years from when the universe first became transparent to light. Before that moment, the universe was too hot and dense for light to travel freely. It was opaque, like looking into a thick fog. But here's where it gets really weird. That cosmic microwave background radiation doesn't show us the Big Bang itself. It shows us the universe when it was about 380,000 years old. Before that, we're blind. We can only theorize about what happened in those first moments based on the physics we understand and the patterns we see in the cosmic microwave background. Those patterns tell an incredible story. They show us that the universe began in an almost perfectly smooth state, with tiny quantum fluctuations that eventually grew into the galaxies and cosmic structures we see today. Those microscopic ripples in the fabric of space-time, smaller than an atom when they formed, grew over billions of years to become galaxy clusters spanning hundreds of millions of light-years. This is cosmic evolution on a scale that makes biological evolution look like a time-lapse video. We're talking about processes that take longer than the current age of the universe to complete, structures so massive that light hasn't had time to travel across them since the beginning of time itself. And speaking of time, let's talk about deep time. Not just the 13.8 billion years since the Big Bang, but the unimaginable stretches of time that lie ahead. The universe is still young. The stars we see today will burn for trillions of years. The red dwarf stars, the most common type in the universe, will continue shining for hundreds of trillions of years. Long after our sun has died and Earth has been consumed, these stellar embers will continue burning in a universe growing ever colder and more empty. Eventually, even the longest-lived stars will burn out. The universe will enter what cosmologists call the degenerate era, when only brown dwarfs, neutron stars, black holes, and scattered planets remain. This era will last from about 10 to the 37th power years to 10 to the 100th power years after the Big Bang. To put that in perspective, if the current age of the universe were 1 second, the degenerate era would last longer than the current age of the universe raised to the power of itself, then raised to that power again, millions of times over. But even that's not the end. After the degenerate era comes the black hole era, when black holes dominate the universe. Through a process called Hawking radiation, even black holes eventually evaporate. The largest ones will take 10 to the 100th power years to completely disappear. That's a 1 followed by 100 zeros, a number so large that if you wrote 1 digit per atom in the observable universe, you wouldn't have enough atoms to write it down. And after that, the heat death era, when the universe reaches maximum entropy. No more stars, no more planets, no more black holes, just elementary particles scattered across an unimaginably vast, cold, empty space, slowly drifting apart as the universe continues to expand forever. The temperature will approach absolute zero. Energy will be spread so thin that nothing interesting can ever happen again. This is the ultimate fate of our universe according to our best current understanding. Not a dramatic collapse or explosion, but a slow fade to black, a cosmic heat death that makes every human drama, every war, every love story, every moment of joy and suffering seem almost infinitely brief and precious by comparison. But here's what makes this even more surreal. Even as we contemplate these vast scales of space and time, we're discovering that the universe might be even stranger than we imagined. Dark energy, the mysterious force that's accelerating the expansion of the universe, makes up about 68% of everything that exists. We don't know what it is. We can't see it directly. We only know it exists because galaxies are flying apart faster than they should be. Dark matter makes up another 27% of the universe. Like dark energy, we can't see it directly. We only know it's there because of its gravitational effects on ordinary matter. Without dark matter, galaxies would fly apart. Stars wouldn't form the way they do. The universe as we know it wouldn't exist, yet we have no idea what dark matter actually is. It could be exotic particles. It could be primordial black holes. It could be something so alien to our experience that we don't even have concepts to describe it. This means that everything we can see and touch and measure, all the atoms that make up every star and planet and living thing, represents less than 5% of the universe. We're living in a cosmos where 95% of everything that exists is completely unknown to us. It's like trying to understand a book when you can only read 1 page out of every 20. And that's just what we can observe within our cosmic horizon. Remember, the observable universe might be just a tiny bubble in an infinite expanse that we can never see. If cosmic inflation theory is correct, and many cosmologists believe it is, then our observable universe is like a single grain of sand on a beach that stretches to infinity in all directions. During the first fraction of a second after the Big Bang, space itself expanded faster than light. Much faster. In a time period shorter than it takes light to travel across a proton, the universe grew from smaller than an atom to larger than a grapefruit. This inflationary period could have created regions of space-time so distant from us that they are forever beyond our cosmic horizon. Each of these regions would be like a separate universe with its own history, its own galaxies, possibly its own laws of physics. They exist, but they might as well be fictional to us because we can never interact with them or observe them in any way. The light from these regions will never reach us because space is expanding too fast between us and them. This creates a profound philosophical problem. If something exists but can never be observed or interact with us in any way, does it really exist in any meaningful sense? Or are we falling into the trap of assuming that our limited perspective represents all of reality? Some physicists take this even further. They propose that our universe is just one bubble in an eternal, ever-expanding multiverse where new universes are constantly being born through quantum fluctuations. Each universe would have its own physical constants, its own version of the laws of nature. Some might have stronger gravity, others weaker. Some might have different numbers of dimensions or different types of particles. In most of these universes, matter as we know it couldn't exist. Stars wouldn't form. Atoms wouldn't be stable. Life would be impossible. But in the tiny fraction where the constants are just right, universes like ours emerge, complete with galaxies and planets and the possibility of life and consciousness. This is called the anthropic principle, and it suggests that we live in a universe that seems fine-tuned for life, not because it was designed, but because we could only exist in a universe where the conditions were right. It's a selection effect. We observe a life-friendly universe because we're here to observe it. In all the other universes where the physics doesn't allow for complexity and life, there's no one around to notice. But this raises another disturbing possibility. If there are infinite universes with infinite variations, then every possible version of reality exists somewhere. There are universes where you made different choices, universes where history unfolded differently, universes where the laws of physics are so alien that conscious beings exist as patterns of pure energy or quantum information. And if that's true, then everything that can happen does happen. Every possible story gets told. Every possible tragedy and triumph plays out somewhere in the vast multiverse. Your life, your choices, your experiences become just one thread in an infinite tapestry of possibility. This is where the sheer scale of existence starts to become not just incomprehensible, but almost unbearable to contemplate. How do you find meaning in a reality so vast that every possible version of yourself exists? How do you make choices that matter when every possible choice is being made by some version of you in some parallel universe? Yet, somehow, we keep looking, we keep measuring, we keep pushing the boundaries of our understanding further and further into the cosmic deep. With each new discovery, the universe reveals itself to be stranger and more magnificent than we ever imagined. We've found planets made of diamond, stars that pulse like cosmic lighthouses, galaxies that collide and merge over billions of years in slow-motion cosmic ballet. We've detected gravitational waves, ripples in space-time itself caused by colliding black holes billions of light-years away. These waves stretched and compressed space by less than 1/10,000th the width of a proton as they pass through Earth, yet we detected them. We built instruments so sensitive they can measure changes in distance smaller than a virus, and used them to eavesdrop on the most violent events in the universe. We've peered back to within a few 100 million years of the Big Bang and watched the first stars ignite in the cosmic dawn. We've mapped the distribution of matter across billions of light years and seen the cosmic web in all its intricate beauty. We've even taken a photograph of a black hole's event horizon, the point of no return where space and time break down. Each discovery reveals new mysteries. The more we learn, the more we realize how little we know. The universe keeps surprising us, keeps showing us phenomena that challenge our understanding of what's possible. Neutron stars that spin 700 times per second, gamma-ray bursts that release more energy in 10 seconds than our sun will produce in 10 billion years, quantum entanglement that links particles across vast distances instantaneously, and through it all we remain here on our small world, orbiting our ordinary star in our unremarkable galaxy, somehow capable of comprehending scales of existence that dwarf us beyond all proportion. We are the universe's way of understanding itself, consciousness arising from matter and energy to contemplate the very cosmos that created it. This perspective shift changes everything about how we experience reality. When you realize that you're not separate from the universe, but are literally the universe experiencing itself subjectively, the question of size becomes deeply personal. You're not just asking how big the universe is, you're asking how big you are, because in the most fundamental sense, you and the universe are the same thing. But let's push deeper into the abyss of scale, because we're about to encounter concepts that will make everything we've discussed seem quaint by comparison. We need to talk about the quantum realm, where the very notion of size breaks down entirely. At the smallest scales, reality becomes probabilistic rather than definite. Particles don't have fixed positions or velocities. They exist in clouds of possibility until the moment they're observed. At the Planck scale, about 10 to the negative 35th meters, space and time themselves become granular. Smaller than this, the concepts of distance and duration lose all meaning. It's like trying to zoom in on a digital photograph until you can see the individual pixels, except in this case, the pixels are the fundamental building blocks of reality itself. Below the Planck length, asking about size is like asking what color feels like or what music tastes like. The question becomes meaningless. Yet here's the mind-bending paradox. These quantum effects, operating at scales trillions of times smaller than an atom, somehow give rise to the entire classical universe. Every star, every galaxy, every structure we've discussed emerges from the strange, probabilistic dance of quantum particles. It's like discovering that all of Shakespeare's plays were written by randomly typing monkeys, except the monkeys are following rules we barely understand and the plays are the entire cosmos. Quantum mechanics suggests that reality might be fundamentally observer-dependent. The act of measurement doesn't just reveal properties that already existed, it actually brings those properties into being. Before you measure a particle's position, it doesn't have a definite position. It exists in what physicists call a superposition of all possible positions simultaneously. This creates a disturbing implication for our understanding of universal size. If reality is observer-dependent, then the size of the universe might depend on who's doing the observing and how they're measuring it. Different observers, with different measurement capabilities, might literally inhabit universes of different sizes. The universe's dimensions become relative, contextual, almost subjective. Some interpretations of quantum mechanics take this even further. The many worlds interpretation suggests that every quantum measurement splits reality into multiple parallel universes, each containing a different outcome. Every time a particle's wave function collapses, the universe branches. With countless quantum events happening every nanosecond throughout the cosmos, reality would be splitting into an incomprehensible number of parallel branches. If this is true, then asking about the size of the universe becomes almost absurd. Which universe? Which branch of reality? The question multiplies into infinity, with each possible measurement creating new universes with their own dimensions and properties. The multiverse becomes not just vast in space, but vast in possibility, containing every conceivable version of reality. But even this barely scratches the surface of how strange things become when we seriously contemplate cosmic scale. Let's talk about something that will make you question whether space and time are even real. According to Einstein's general relativity, what we perceive as gravity isn't actually a force, it's the curvature of space-time itself. Massive objects literally bend the fabric of reality around them. Near extremely massive objects like black holes, this curvature becomes so extreme that it warps our normal understanding of distance and duration beyond recognition. Time slows down, space contracts. The usual rules that govern how we measure size simply break down. If you fell toward a black hole, from your perspective, you'd cross the event horizon in finite time, but to an outside observer, you'd appear to slow down and freeze at the horizon, your image gradually fading as it's stretched and reddened by the intense gravitational field. Inside the black hole, things get even stranger. At the center lies the singularity, a point where matter is compressed to infinite density and space-time curvature becomes infinite. Our physics equations literally break down. They produce infinities and meaningless results. We don't know what happens there because our mathematical tools for describing reality simply fail. Some physicists believe that singularities don't actually exist, that quantum effects prevent matter from collapsing to a true point of infinite density. Others propose that black holes are gateways to other regions of space-time, possibly other universes entirely. The math allows for these possibilities, but we have no way to test them. The event horizon is a one-way membrane. Information that crosses it can never return to tell us what lies beyond. This creates a profound epistemological crisis. There are regions of the universe that are forever beyond our ability to investigate. Not just practically beyond our reach, but theoretically unknowable. The The universe contains secrets that it will never reveal, mysteries that by their very nature must remain mysterious. We can theorize and calculate, but we can never know for certain what happens in the heart of a black hole or beyond our cosmic horizon, and this brings us to one of the most unsettling aspects of contemplating universal scale. The more we learn, the more we realize how much we don't know. Each answer reveals 10 new questions. Each discovery opens up new realms of mystery. The universe isn't just big in terms of space and time. It's big in terms of mystery, complexity, and the sheer number of phenomena we don't understand. Consider dark energy, which makes up 68% of the universe but remains completely mysterious. We know it exists because we can measure its effects on cosmic expansion, but we have no idea what it actually is. It could be a property of space itself, constantly creating new energy as the universe expands. It could be evidence of extra dimensions beyond the 3 spatial dimensions we experience. It could be a sign that our understanding of gravity is fundamentally flawed. Some theories suggest that dark energy is increasing over time, that the acceleration of cosmic expansion is itself accelerating. If this continues, the universe faces a fate called the Big Rip. Billions of years from now, the expansion would become so rapid that it would overcome all other forces. First, galaxy clusters would be torn apart, then individual galaxies, then solar systems. Eventually, even atoms themselves would be ripped apart as space expands faster than the speed of light between their components. But here's what makes this scenario particularly disturbing. The Big Rip wouldn't happen everywhere at once. It would propagate outward at the speed of light. There would be a moment when some regions of the universe are experiencing the ultimate dissolution of matter, while others remain blissfully unaware that their destruction is racing toward them. The universe would literally tear itself apart, piece by piece, in a cascade of cosmic annihilation. Yet even this apocalyptic scenario might not be the end of the story. Some theories in quantum cosmology suggest that universes can spontaneously emerge from quantum vacuum fluctuations. The same quantum processes that create virtual particles in empty space might occasionally create entire new universes. If this is possible, then even the heat death of our universe might not be final. Given infinite time, quantum tunneling could create new Big Bangs, new cosmic expansions, new realities emerging from the void. This idea, called eternal inflation, suggests that universes are constantly being born throughout an infinite multiverse. Our Big Bang wasn't a unique event, but just one bubble of expansion in an eternal cosmic foam. New universes branch off constantly, each with its own physical laws and cosmic history. The multiverse becomes not just spatially infinite, but temporally eternal, constantly creating new realities without end. But here's where we encounter something that should make you profoundly uncomfortable. If universes can emerge spontaneously from quantum fluctuations, then the probability that you're living in a naturally evolved universe becomes vanishingly small. In an infinite multiverse with infinite random fluctuations, it's far more likely that your consciousness is just a temporary arrangement of particles that happen to pop into existence, complete with false memories of a past that never actually occurred. This is called the Boltzmann brain paradox, and it's one of the most disturbing implications of taking cosmic infinity seriously. If random quantum fluctuations can create anything, they're much more likely to create a single conscious observer with implanted memories than an entire universe with billions of years of consistent history. Statistically speaking, you're probably just a disembodied brain floating in empty space, hallucinating this entire reality. The math is inescapable. In an infinite multiverse, every possible arrangement of matter will occur infinitely many times. But simple arrangements are much more probable than complex ones. A brain that spontaneously forms with false memories of reading this sentence is trillions of times more likely than a universe that actually evolved naturally to produce genuine brains and genuine history. This paradox reveals something deeply unsettling about the relationship between infinity and probability. When you're dealing with infinite possibilities, even the most improbable events become not just possible, but inevitable, and more disturbingly, the most probable explanation for your existence becomes that you're a temporary hallucination in an otherwise empty cosmos. Some physicists try to resolve this paradox by arguing that the multiverse isn't truly infinite, or that there are selection effects that make naturally evolved observers more likely despite the statistical improbability. But these solutions require making assumptions that can never be tested. We're forced to take it on faith that our reality is real rather than a quantum mirage. This brings us to perhaps the most profound question raised by contemplating universal scale. In a cosmos this vast, this strange, this full of possibilities we can barely imagine, what does it mean to exist? What does it mean to be conscious? What does it mean to matter? Traditional human meaning-making systems break down when confronted with these scales. Religions that speak of humanity's special place in creation struggle to explain why we'd be placed on one tiny world in one ordinary galaxy among trillions. Philosophies that emphasize individual significance seem almost laughable when set against the backdrop of cosmic immensity and eternal time. Yet somehow, meaning persists. Love still feels profound even in an infinite multiverse. Beauty still moves us even when we know that every possible arrangement of matter exists somewhere. Consciousness still seems miraculous even when we understand that it emerged from quantum processes we can barely comprehend. Perhaps this is the deepest mystery of all, not the size of the universe, but the persistence of meaning and wonder in the face of that size. Not the complexity of cosmic structure, but the fact that simple arrangements of matter can contemplate that complexity. Not the vastness of space and time, but the ability of conscious beings to transcend their limitations and touch the infinite with their minds. We are pattern recognition machines evolved to find food and avoid predators on an African savanna. Yet somehow we've developed the ability to peer into the heart of atoms and across billions of light years. We can calculate the mass of black holes we'll never see and predict the behavior of particles too small to ever observe directly. We can conceive of infinities that dwarf even our expanded understanding of cosmic scale. This cognitive achievement is perhaps more remarkable than any of the structures we've discovered in the universe. A kilogram of neural tissue operating on about 20 watts of power has mapped the cosmic web and detected gravitational waves. The same brain that worries about paying bills and remembers where it left its keys can also contemplate the heat death of the universe and the possibility of infinite parallel realities. But there's something else worth considering as we grapple with these incomprehensible scales. The universe isn't just big in space and time. It's big in information. Every particle, every field, every quantum state represents information, and the total amount of information in the observable universe is staggering beyond comprehension. Consider that every atom's position, velocity, and quantum state represents information. Multiply that by the estimated 10 to the 80th power atoms in the observable universe. Then factor in all the quantum fields, virtual particles, and dark matter we can't directly observe. The total information content becomes a number so large that it makes our previous cosmic measurements look tiny by comparison. Some physicists propose that this information is fundamental, that matter and energy are just different ways of organizing information. In this view, the universe isn't made of stuff. It's made of data. Reality becomes a vast computational process, with physical laws serving as the algorithm that determines how information flows and transforms. If this is true, then consciousness might be best understood as information processing. Your thoughts, memories, and experiences would be patterns of information flow within the larger informational structure of the universe. You wouldn't just be made of star stuff. You'd be made of cosmic data, a temporary eddy in the universal flow of information. This perspective raises profound questions about the nature of identity and continuity. If you're a pattern of information, then what makes you you? If that pattern could be copied exactly, would there be two of you? If it could be transferred to a different substrate, would you still be you? These aren't just philosophical thought experiments anymore. They're questions we may need to answer as our understanding of consciousness and information advances. But even this informational perspective on reality pales in comparison to some of the more exotic possibilities suggested by cutting-edge physics. String theory proposes that the fundamental constituents of reality aren't particles at all, but tiny vibrating strings existing in 11 dimensions. Most of these dimensions are curled up so small that we can't perceive them directly, but they influence everything that happens in our familiar three-dimensional world. If string theory is correct, then the universe is even stranger and more complex than we've imagined. Those extra dimensions could contain entire hidden realities, pocket universes folded into the fabric of space-time at every point. The familiar world of matter and energy might be just a thin slice of a much richer, more complex reality. Some versions of string theory allow for the possibility of brain worlds, where our entire universe exists on a three-dimensional surface embedded in higher dimensional space. Other universes might exist on parallel branes, separated from us by microscopic distances in the extra dimensions, but completely inaccessible through normal space. Gravity might leak between these branes, which could explain why it's so much weaker than the other fundamental forces. These ideas push our understanding of cosmic scale into realms that barely qualify as science fiction. We're talking about realities so alien to our experience that we can only describe them through abstract mathematics. Yet these mathematical descriptions make predictions that we can test, at least in principle. The Large Hadron Collider and other particle accelerators probe energies high enough to potentially detect signatures of extra dimensions or parallel branes. But here's what makes all of this even more surreal. Even if we confirm the existence of extra dimensions and parallel universes, even if we map the complete structure of reality across all scales from the quantum to the cosmic, we still won't have answered the fundamental question of why anything exists at all. The universe could have been empty. The laws of physics could have been different. Consciousness could have never emerged. Yet here we are, in a reality so rich, so complex, so full of beauty and mystery that we can barely begin to comprehend it. The sheer improbability of existence itself becomes another scale to contemplate, another dimension of cosmic vastness that challenges our understanding. Some philosophers and physicists argue that existence is somehow necessary, that reality couldn't have been any other way. Others propose that all possible realities exist simultaneously, and we simply find ourselves in one of the branches that allows for observers. Still others suggest that consciousness itself plays a fundamental role in bringing reality into being, that the universe exists because it can be observed. These questions push us beyond science into the realm of pure metaphysics. Yet they're questions that naturally arise when we seriously contemplate the true scale of existence. The universe isn't just big, it's so big that it forces us to question the nature of bigness itself. It's so complex that it challenges our understanding of complexity. It's so improbable that it makes us wonder about the nature of probability and possibility, and through it all, we remain here, conscious observers in an unconscious cosmos, pattern recognition systems capable of recognizing patterns that span the entire universe. We can hold in our minds concepts that dwarf our physical existence. We can imagine infinities that make our actual infinity look finite. We can contemplate possibilities that make our reality seem like just one note in an infinite symphony of existence. This is perhaps the most remarkable thing of all. Not that the universe is unimaginably vast, but that we can imagine it anyway. Not that reality is incomprehensibly complex, but that we keep trying to comprehend it. Not that existence is improbable, but that improbable existence has produced beings capable of calculating that improbability. We are the universe's greatest miracle and its deepest mystery. We are matter that thinks, energy that dreams, information that experiences wonder. We are the cosmos awakening to itself, asking questions about its own nature, marveling at its own complexity and beauty. And as we stand here on the edge of infinity, peering into the cosmic deep with instruments and mathematics and imagination, we realize that the question isn't really how big the universe is. The question is how big we are. How far can consciousness reach? How much can finite minds comprehend about infinite reality? How much meaning can brief, improbable arrangements of matter create in the face of eternal, impersonal forces? The answers to these questions are still being written. Every observation we make, every theory we develop, every moment of wonder we experience adds another page to the story. We are not just observers of the cosmic drama. We are participants in it. We are characters in the universe's attempt to understand itself, and that understanding is still growing, still deepening, still reaching towards scales and mysteries we haven't even begun to imagine. The universe keeps revealing new layers of complexity, new dimensions of vastness, new reasons for wonder and humility and awe. Tonight, we're about to venture into territory that will make everything we've discussed feel like a warm-up, because the universe isn't just vast in the ways we've explored, it's vast in ways that break our brains entirely. We're about to encounter scales so extreme, concepts so alien, that the very words we use to describe them start to lose their meaning. Let's talk about what happens when we try to measure the unmeasurable. When astronomers look at the most distant galaxies, they're not just seeing far-away objects, they're seeing the universe when it was fundamentally different. Those ancient galaxies appear smaller, more chaotic, more violent than anything we see nearby. They're glimpses of cosmic adolescence, when the universe was still figuring out how to make stars and organize matter into the elegant structures we see today. But here's where it gets genuinely disturbing. The light from these distant galaxies has been traveling toward us for so long that the galaxies themselves have aged and evolved beyond recognition. By the time their ancient light reaches our telescopes, those galaxies have lived entire cosmic lifetimes. They've formed new stars, experienced collisions, possibly died completely. We're seeing ghosts, cosmic phantoms of objects that may no longer exist in any recognizable form. This creates a bizarre temporal landscape. Look in one direction, and you see the universe as it was 12 billion years ago. Look in another direction, and you see it as it was 10 billion years ago. Every point in the sky represents a different moment in cosmic history. We're not looking at the universe as it is. We're looking at an archaeological dig site scattered across time itself. And this is just the beginning of how strange things become when we try to grasp the true scale of existence. Let's dive deeper into something that should keep you awake tonight, the cosmic horizon problem. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang, we see that it has almost exactly the same temperature in every direction. This seems normal until you realize the problem. Those regions of the early universe were so far apart that light hadn't had time to travel between them. They couldn't have communicated with each other. They couldn't have exchanged energy or information, yet somehow they all reached precisely the same temperature. It's like finding that every grain of sand on every beach in the world is exactly the same size, despite those beaches never having any contact with each other. The solution to this puzzle is cosmic inflation. In the first tiny fraction of a second after the Big Bang, space itself expanded faster than light. Much faster. The entire observable universe inflated from a region smaller than a proton to larger than a grapefruit in less time than it takes light to cross the nucleus of an atom. This expansion was so rapid, so violent, that it stretched quantum fluctuations to cosmic scales. But here's what makes this truly mind-bending. If inflation happened once, it's probably still happening. Somewhere beyond our cosmic horizon, space might still be inflating at exponential rates, creating pocket universes that balloon into existence and then disconnect from each other forever. Our entire observable universe might be just one bubble in an eternal sea of inflating space, forever cut off from the countless other bubbles being born around us. This is eternal inflation, and it suggests that reality is not just big, but infinitely creative. New universes are being born every moment, each with randomly assigned physical constants. Most of them are stillborn, unable to form stable matter or lasting structures. But occasionally, by pure chance, a bubble universe emerges with just the right properties to create stars, planets, and eventually life. We're living in one of the winners, a cosmic lottery ticket that happened to have the right numbers. But for every universe like ours, there might be trillions where the physics went wrong, where matter collapsed too quickly, or never clumped together at all, where time runs backward, or where the fundamental forces are so different that atoms can't exist. And here's where the mathematics become almost unbearable to contemplate. If eternal inflation is real, then every possible universe exists somewhere, not just similar universes, but exact duplicates. In an infinite sea of possibilities, probability demands that every possible arrangement of matter must occur, and occur infinitely many times. This means there are infinite copies of you reading these words right now, infinite versions where you made different choices, lived different lives, had different thoughts at this exact moment. There are versions where history unfolded differently, where the laws of physics are subtly altered, where consciousness evolved in completely alien ways. But even infinity isn't the strangest scale we need to grapple with. Let's talk about something that will make you question whether size means anything at all. In the quantum world, particles don't have definite sizes or positions. They exist as probability clouds, waves of potential that only collapse into specific states when observed. An electron, for instance, doesn't orbit the nucleus of an atom like a planet orbiting a star. It exists in a quantum superposition, simultaneously occupying multiple positions around the nucleus until something forces it to choose. Before measurement, asking about its exact location is meaningless. It's everywhere and nowhere at once. Scale this up to cosmic proportions, and you get something that should terrify you. If the universe itself is a quantum system, and many physicists believe it is, then it might exist in a superposition of all possible states. Every possible history, every possible arrangement of matter, every possible outcome exists simultaneously until some cosmic measurement forces reality to choose. This is the many worlds interpretation of quantum mechanics applied to cosmology, and it suggests that the universe isn't just big in space and time, it's big in possibility. Every quantum event that could happen does happen, splitting reality into parallel branches. The universe becomes a vast tree of possibilities, with every branch representing a different version of history. You're not just living in one universe, you're living in all possible universes simultaneously until the act of observation forces your consciousness to experience one particular branch. But the other branches don't disappear, they continue evolving in parallel, carrying other versions of you living other versions of your life. This creates a scale problem that makes all our previous measurements look trivial. How do you measure the size of something that contains every possible version of itself? How do you count the number of galaxies when every galaxy exists in infinite variations across infinite parallel realities? The mathematics suggest that the total information content of this quantum multiverse is not just infinite, but infinitely infinite. There are different levels of infinity, and the multiverse appears to operate at the highest levels we can conceive. It's not just that there are infinitely many universes, there are infinitely many different types of infinity, each containing infinitely many universes of infinitely many different kinds. But let's push even deeper into the abyss of scale, because we haven't even talked about what might exist beyond the multiverse itself. Some theories in quantum gravity suggest that even our concepts of space and time are emergent properties of something more fundamental. reality might be built from pure information, with space and time emerging from the relationships between bits of cosmic data. In this view, asking about the size of the universe is like asking about the size of mathematics itself. It's a category error. Size is a property that emerges within certain informational structures, but the underlying reality that generates those structures might not have size in any meaningful sense. This is where human language breaks down completely. We're trying to describe concepts that exist outside the framework of space and time, using words that only make sense within that framework. It's like trying to explain color to someone who has never seen light, or music to someone who has never heard sound. Yet somehow we keep pushing forward. We keep building bigger telescopes, more sensitive detectors, more sophisticated theories. We keep reaching toward the infinite with finite minds, grasping for understanding that might forever remain just beyond our reach. And here's what makes this quest both noble and absurd. Every step we take toward understanding the true scale of reality reveals how much more there is to understand. Every answer opens up 10 new questions. Every discovery shows us new horizons we didn't even know existed. We thought the Milky Way was the entire universe until we discovered other galaxies. We thought those galaxies were moving randomly until we discovered cosmic expansion. We thought expansion was slowing down until we discovered dark energy. Each revelation has made the universe stranger, larger, more mysterious than we previously imagined. Now we're discovering that our observable universe might be just a tiny bubble in an infinite multiverse. That reality itself might be a quantum superposition of all possibilities. That consciousness might play a fundamental role in determining which version of reality we experience. That the very concepts of space, time, and matter might be illusions emerging from deeper, more abstract structures. Where does it end? Does it end? Or are we trapped in an eternal regression of scales within scales, mysteries within mysteries, infinities within infinities? Are we like microscopic beings living on a grain of sand, trying to understand the beach, the continent, the planet, the solar system, the galaxy, the universe, the multiverse, and whatever lies beyond? The ancient Greeks had a concept called the music of the spheres. They believed that the movement of celestial bodies created a harmony that permeated the cosmos. We've discovered that they were more right than they knew. The universe does sing, but its song is stranger and more beautiful than they ever imagined. Gravitational waves ripple through space-time like cosmic sound waves, carrying the music of colliding black holes and merging neutron stars. The cosmic microwave background radiation hums with the echoes of the Big Bang itself. Pulsars beat like cosmic drums, keeping time for the galaxy's rotation. Even the quantum vacuum itself vibrates with virtual particles popping in and out of existence. We're not just observing this cosmic symphony, we're part of it. The atoms in our bodies were forged in stellar furnaces and scattered by supernovae. We're made of stellar music, cosmic harmonies given flesh and consciousness. When we listen to the universe, we're listening to our own origin story told in the language of physics and mathematics. But the music is getting stranger. Dark energy is stretching space itself, changing the tempo of cosmic expansion. Dark matter is playing a bass line we can hear but not see. Quantum entanglement is creating instantaneous connections across vast distances, like cosmic strings vibrating in perfect synchrony regardless of the space between them. And consciousness itself might be part of the orchestra. The act of observation changes quantum states, influences the behavior of particles, possibly even determines which version of reality we experience. We're not just listening to the music of the spheres, we might be composing it as we observe it, creating reality through the very act of trying to understand it. This brings us to perhaps the most profound implication of cosmic scale. We're not separate from the universe we're studying. We're not outside observers looking in. We're the universe observing itself, consciousness arising from matter and energy to contemplate the very processes that created it. We are cosmic self-awareness, the mechanism by which the universe becomes conscious of its own existence. Every time you look up at the night sky, you're participating in the universe's attempt to understand itself. Every scientific discovery, every moment of wonder, every question about existence is the cosmos awakening to its own nature. We're not just studying the universe, we are the universe studying itself. This perspective transforms every human achievement into a cosmic milestone. When we discovered that the Earth orbits the Sun, that was the universe figuring out its own structure. When we split the atom, that was the cosmos learning to manipulate its own fundamental components. When we detected gravitational waves, that was reality itself learning to listen to its own heartbeat. And we're just getting started. We're building telescopes that will see further back in time, particle accelerators that will probe deeper into the quantum realm, computers that will simulate entire universes. We're on the verge of discoveries that will make our current understanding look as primitive as ancient astronomy. We might detect signs of life around other stars, proving that consciousness is not unique to Earth. We might discover evidence of extra dimensions, revealing that our three-dimensional reality is just a shadow of something far more complex. We might even make contact with other forms of intelligence, other ways the universe has developed self-awareness. But even if we achieve all of this, even if we map every galaxy and understand every force and decode every mystery, we'll still be left with the ultimate question. Why does anything exist at all? Why is there something rather than nothing? Why did the universe choose to become conscious of itself through beings like us? These questions push us beyond science into the realm of pure wonder. They remind us that no matter how much we learn, no matter how far our instruments can see, no matter how sophisticated our theories become, we'll always be finite beings grappling with infinite mysteries. And maybe that's exactly as it should be. Maybe the universe is designed to be just comprehensible enough to inspire wonder, but just mysterious enough to keep us searching. Maybe consciousness evolved not to solve the cosmic puzzle, but to appreciate its beauty, complexity, and ultimate inscrutability. We are the universe's way of marveling at itself. We are matter that has learned to wonder, energy that has developed curiosity, information that has become capable of awe. In a cosmos that spans scales from the quantum to the infinite, we represent something unprecedented. We are the bridge between the infinitely small and the infinitely large conscious beings, capable of contemplating both the structure of atoms and the fate of galaxies. And as we stand here on our small world, in our brief moment of cosmic time, we're participating in something magnificent. We're part of the universe's ongoing project of self-discovery. Every question we ask, every observation we make, every theory we develop adds another page to the cosmos's autobiography. The universe is not just big. It's so big that it created beings capable of asking how big it is. It's so complex that it generated intelligence capable of contemplating that complexity. It's so beautiful that it evolved consciousness capable of appreciating that beauty. We are the universe's greatest achievement and its deepest mystery. We are the cosmos made conscious, infinity made intimate, eternity made personal. In us, the universe has found a way to transcend its own vastness and touch the infinite through finite minds, and the story is far from over. We're still writing it, still discovering it, still living it with every breath we take and every thought we think. The universe is still expanding, still evolving, still finding new ways to surprise and delight and terrify us with its inexhaustible creativity. Tonight, as you drift off to sleep, remember that you're not just lying in bed on a planet in a solar system in a galaxy. You're riding a wave of cosmic expansion that began 13.8 billion years ago and will continue for trillions of years to come. You're participating in the universe's journey from simplicity to complexity, from unconsciousness to awareness, from isolation to connection. You are star stuff, contemplating stars, cosmic dust that learned to dream, quantum fluctuations that developed the ability to wonder about quantum mechanics. You are the universe's way of experiencing wonder, and wonder is perhaps the most profound response to the question of cosmic scale. The universe is bigger than we can imagine, stranger than we can conceive, more beautiful than we can express. But somehow, impossibly, we can still reach toward it with our minds and touch the infinite with our finite understanding. We can still ask the questions that matter, even if we can never fully answer them. And in that reaching, in that questioning, in that eternal human hunger to understand our place in the cosmic story, we find something that transcends scale itself. We find meaning that doesn't depend on size, purpose that doesn't require infinity, significance that emerges not from our cosmic importance, but from our cosmic curiosity. We are small beings in a vast universe, but we are the beings who discovered that vastness. We are brief sparks in eternal time, but we are the sparks who learned to measure eternity. We are improbable arrangements of matter in an impersonal cosmos, but we are the arrangements that made the cosmos personal through the simple act of caring about it. The universe is unimaginably big, but tonight, as you contemplate that bigness, you make it just a little bit smaller by holding it in your mind. You make it just a little bit more human by wondering about it. You make it just a little bit more meaningful by caring about the answer to the question that has no final answer. How big is the universe really? It's exactly big enough to contain the consciousness capable of asking that question. It's precisely vast enough to inspire the wonder that makes us human. It's just the right size to be both humbling and inspiring, both overwhelming and intimate, both infinite and personal. And that might be the most remarkable scale of all. But let's venture into something that will shatter even that perspective, because we haven't talked about the most disturbing possibility of all. What if the universe isn't just unimaginably big? What if it's getting bigger in ways that violate everything we thought we knew about the nature of space itself? Recent observations suggest that the expansion of the universe isn't just accelerating, it might be accelerating at an accelerating rate. Dark energy, that mysterious force we can't see or understand, appears to be growing stronger over time. Space itself is being created at an exponential rate, pushing galaxies apart faster and faster with each passing moment. Think about what this means. Right now, there are galaxies receding from us so quickly that their light will never reach us. No matter how long we wait, they exist, but they're moving away from us faster than the speed of light itself. Not because they're traveling through space that fast, but because space itself is expanding between us and them at superluminal speeds. But it gets worse. If this acceleration continues, if dark energy keeps growing stronger, we face a future so bizarre it makes the heat death of the universe look optimistic. The Big Rip. A cosmic apocalypse where the expansion of space becomes so violent that it tears apart everything that exists. First, galaxy clusters would be ripped apart as space expands faster than gravity can hold them together. Then, individual galaxies would dissolve as their constituent stars are dragged away from each other by the expanding fabric of reality itself. Solar systems would be next, with planets torn from their orbits as space stretches between them and their suns. Eventually, even atoms would be destroyed. The forces that hold protons and neutrons together would be overwhelmed by the expansion of space happening at subatomic scales. Matter itself would dissolve into a soup of isolated particles, each one racing away from every other one as space expands between them faster than any force can counteract. And here's the truly terrifying part. This wouldn't happen everywhere at once. The Big Rip would propagate outward at the speed of light. There would be a moment when some regions of the universe are experiencing total annihilation, while others remain blissfully unaware that a wave of cosmic destruction is racing toward them. The universe would literally tear itself apart, piece by piece, in a cascade of expanding emptiness. But even this scenario assumes we understand what dark energy actually is. And we don't. Not even close. It could be a property of space itself, constantly creating new energy as the universe expands. It could be evidence that we live in a higher dimensional reality where our three-dimensional space is just a surface floating in a larger cosmic structure. It could be leakage from parallel universes pressing against our own reality, like soap bubbles in infinite foam. Some theories suggest that dark energy isn't constant at all, but varies depending on the local structure of space-time. In regions where space is curved by massive objects, dark energy might behave differently than in the empty voids between galaxy clusters. This could create a patchwork universe where different regions expand at different rates, leading to cosmic structures we can barely imagine. Picture vast islands of space-time where galaxies huddle together, surrounded by expanding oceans of emptiness. These cosmic archipelagos would become increasingly isolated as the voids between them grow larger and larger. Eventually, beings living in one island would have no way to detect or communicate with beings in another. Each island would become its own observable universe, complete and self-contained. But let's push deeper into the mathematical abyss, because even our expanded understanding of cosmic scale pales in comparison to what happens when we take seriously the possibility that information, not matter or energy, is the fundamental constituent of reality. Every particle, every field, every quantum state represents information, but not just any information. Quantum information, which behaves according to rules so strange they make ordinary physics look intuitive. Quantum bits, or qubits, can exist in superposition states, representing multiple values simultaneously until they're observed. Scale this up to the entire universe, and you get something that should break your brain entirely. The universe might be a vast quantum computer, processing information on scales we can barely comprehend. Every physical process, from the collision of galaxies to the decay of subatomic particles, would be a computational operation in this cosmic computer. But here's where it gets genuinely disturbing. If the universe is computational, then consciousness might be just another form of information processing. Your thoughts, memories, and experiences would be patterns of information flow within the larger computational structure of reality. You wouldn't just be made of star stuff. You'd be made of cosmic data, a temporary eddy in the universal flow of information. This raises questions that should keep you awake for weeks. If consciousness is information processing, then what distinguishes you from any other information processing system? Is there a fundamental difference between your brain and a sufficiently complex computer? Between your thoughts and the quantum calculations happening in every atom? Some physicists take this even further. They propose that consciousness might be a fundamental property of information itself, like mass or electric charge. In this view, every information processing system, from electrons to galaxies, possesses some rudimentary form of consciousness. The universe wouldn't just be computational, it would be conscious, aware of itself at every scale from the quantum to the cosmic. This is panpsychism, and it suggests that the question of cosmic scale becomes deeply personal. You're not just asking how big the universe is, you're asking how big consciousness is. Because if consciousness is fundamental, then every particle, every star, every galaxy might possess some form of subjective experience. Imagine what it would be like to be a galaxy. Your thoughts would unfold over millions of years. Your memories would span cosmic epochs. Your dreams would be the birth and death of solar systems. The collision with another galaxy wouldn't be a violent catastrophe, but perhaps a moment of cosmic intimacy, two vast minds touching across the void. Or consider the consciousness of a black hole. Time slows to a crawl near the event horizon, so a black hole's thoughts might unfold over billions of years of external time. Its memories would stretch back to the formation of the first stars. Its awareness would encompass everything that ever fell past its event horizon, preserved forever in the twisted space-time near the singularity. But even these cosmic minds would be dwarfed by the consciousness of the universe itself. If the cosmos as a whole possesses awareness, Its thoughts would span the entire history of existence. It would remember the Big Bang, dream the formation of galaxies, contemplate the heat-death of reality. Every human thought, every moment of wonder or terror or love, would be just a fleeting fluctuation in the vast neural network of cosmic consciousness. This perspective transforms our understanding of scale entirely. We're not just physical beings in a physical universe. We're thoughts in the mind of God, patterns of information in a cosmic consciousness that spans space and time and possibility itself. When we contemplate the universe, we're participating in its contemplation of itself. When we wonder about existence, we're giving voice to the cosmos's own existential questions. But let's venture even deeper into the rabbit hole of scale, because we haven't talked about what happens when you try to measure the universe from the inside. Every measurement we make, every observation we conduct, changes the system we're observing. This is true at the quantum level, where the act of measurement collapses wave functions and determines reality, but it might also be true at cosmic scales. If the universe is a quantum system, and many physicists believe it is, then our observations of it might be determining its properties. The size of the universe, the value of physical constants, the structure of space-time itself might depend on how we choose to measure them. Reality becomes observer-dependent, not just at the microscopic scale, but at the cosmic scale as well. This creates a paradox that should make you question everything you think you know about existence. If the universe's properties depend on observation, then how can we ever know what it's really like when no one is looking? How can we measure something that changes in response to being measured? Some interpretations of quantum mechanics suggest that the universe exists in a superposition of all possible states until conscious observers force it to choose specific properties. Before humans evolved to observe the cosmos, it might have existed in a quantum haze of all possible sizes, all possible structures, all possible histories simultaneously. Our presence as observers might be literally creating the universe we observe, not just discovering its properties, but determining them through the act of observation itself. The cosmos might be a collaborative creation between objective reality and subjective consciousness, neither fully real without the other. This leads to a disturbing conclusion. The universe might not have a definite size at all. It might exist in a quantum superposition of all possible sizes until someone tries to measure it. Each measurement would collapse the cosmic wave function, forcing reality to choose a specific scale, but different observers, using different measurement techniques, might collapse it in different ways, creating different versions of cosmic reality. You and I, looking at the same universe, might literally be seeing different universes. The cosmos I observe when I try to measure its size might be fundamentally different from the cosmos you observe when you try to measure it. We'd be living in overlapping but distinct realities, each shaped by our individual acts of observation. But even this mind-bending possibility pales in comparison to what happens when we consider the role of time in cosmic measurement. We've been talking about the size of the universe as if it's a fixed property, something we can measure once and know forever. But the universe is expanding, evolving, changing in ways we're only beginning to understand. The universe you're observing right now is different from the universe that existed a second ago. Not just because it's slightly larger, but because every quantum interaction, every stellar birth and death, every thought in every conscious mind has changed the total information content of reality. The cosmos is not a static structure, but a dynamic process, constantly becoming something new. This temporal dimension of scale creates paradoxes that make spatial infinity look simple. How do you measure the size of something that's constantly changing? How do you count the galaxies in a universe where new ones are forming while others are being destroyed? How do you determine the age of a cosmos where time itself might be emerging from more fundamental processes? Some theories in quantum gravity suggest that time is not fundamental but emergent. What we experience as the flow of time might be just a byproduct of increasing entropy, the universe's tendency toward disorder. At the deepest level of reality, past, present, and future might exist simultaneously in what physicists call the block universe. If this is true, then asking about the size of the universe becomes a question about which slice of the block universe you're examining. The cosmos has a different size at every moment of cosmic time, and all of these sizes exist equally. The universe is simultaneously the size it was at the Big Bang, the size it is now, and the size it will be in the heat-death era billions of years from now. But we experience only one slice at a time, moving through the block universe like a spotlight illuminating different sections of an infinite sculpture. Our perception of cosmic expansion, of galaxies receding and space stretching, would be just an artifact of our limited perspective, like watching a movie and thinking the images are actually moving when they're really just static frames shown in sequence. This block universe perspective makes the question of cosmic scale even more surreal. The universe doesn't just have size in space, it has size in time, extending from the Big Bang to the heat death and possibly beyond. But from a higher dimensional perspective, all of cosmic history would be visible simultaneously, like looking at a vast four-dimensional sculpture where every moment of existence is equally real and present. Conscious beings like us would be four-dimensional worms extending through time, with our birth at one end and our death at the other. Every thought we've ever had, every decision we've ever made, every moment of joy or sorrow would be permanently etched into the structure of space-time. We wouldn't just exist in the universe, we'd be part of its eternal, unchanging architecture. But even this expanded view of cosmic scale might be missing the deepest layer of reality. Some theories suggest that space and time themselves are emergent properties of something more fundamental. Just as temperature emerges from the average motion of molecules, space-time might emerge from the interactions of more basic entities that exist outside our familiar framework of physics. These fundamental entities might not have size in any meaningful sense. They might not exist at specific locations or times. They might be pure relationships, patterns of information that generate the appearance of space and time when viewed from certain perspectives. Reality at its deepest level might be more like mathematics than matter, more like logic than physics. If this is true, then asking about the size of the universe is like asking about the size of the number 7. It's a category error, a confusion between different levels of description. Size is a property that emerges within certain informational structures, but the underlying reality that generates those structures might be beyond spatial concepts entirely. This brings us to perhaps the most profound implication of taking cosmic scale seriously. The universe might not just be bigger than we can imagine, it might be bigger than imagination itself. It might transcend not just our ability to measure it, but our ability to conceive of measurement at all. We're finite beings using finite concepts to try to understand something that might be fundamentally infinite in ways we can't even define. Every scale we discover, from the quantum to the cosmic, might be just another layer in an endless hierarchy of scales within scales, realities within realities, infinities within infinities. And yet, somehow, we keep pushing forward. We keep building bigger telescopes, more sensitive detectors, more sophisticated theories. We keep reaching toward the unreachable with our limited but determined minds. We keep asking questions that might have no answers, pursuing understanding that might be forever beyond our grasp. This persistence in the face of cosmic inscrutability might be the most remarkable thing about human consciousness. We're not just pattern recognition machines or information processing systems. We're beings capable of wonder, creatures driven by curiosity to explore realms that dwarf our existence beyond all proportion. We stand on a tiny world orbiting an ordinary star in an unremarkable galaxy, yet we can contemplate the structure of reality across scales from the Planck length to the cosmic horizon and beyond. We can imagine infinities that make our actual infinity look finite. We can conceive of possibilities that make our reality seem like just one note in an infinite symphony of existence. This cognitive achievement is perhaps more remarkable than any of the structures we've discovered in the universe. A few pounds of neural tissue operating on the energy of a dim light bulb can map the cosmic web and detect gravitational waves. The same brain that worries about mundane concerns can also contemplate the heat death of the universe and the possibility of infinite parallel realities. But there's something else worth considering as we grapple with these incomprehensible scales. The universe isn't just vast in space and time and possibility, it's vast in mystery. Every answer we discover reveals 10 new questions. Every observation opens up new realms of the unknown. The more we learn, the more we realize how much we don't know. This expanding frontier of mystery might be the universe's greatest gift to conscious beings. It ensures that wonder never dies, that curiosity always has new territories to explore, that the journey of discovery never reaches a final destination. In a cosmos that contains infinite mysteries, consciousness can never be bored, never run out of questions to ask or problems to solve. Perhaps this is why the universe is structured the way it is. Perhaps consciousness evolved not to solve the cosmic puzzle completely, but to participate in its eternal unfolding. We're not meant to understand everything, but to keep trying. We're not designed to reach final answers, but to keep asking better questions. In this view, the size of the universe becomes less important than our response to that size. The cosmos is precisely vast enough to inspire humility without crushing hope, complex enough to reward investigation without yielding all its secrets, mysterious enough to generate wonder without descending into incomprehensibility. We are the universe's way of marveling at itself, and marvel we do. Every time we look up at the night sky, every time we peer through a telescope or contemplate an equation or simply wonder about our place in the cosmic story, we're participating in something magnificent. We're giving the universe a way to experience awe at its own existence. And that awe, that capacity for wonder in the face of the infinite, might be the most profound response to cosmic scale. Not fear or despair at our insignificance, but gratitude and amazement that we exist at all in a reality so rich, so complex, so full of beauty and mystery that we can spend entire lifetimes exploring it and barely scratch the surface. The universe is unimaginably big, but it's also unimaginably generous. It has given us consciousness capable of contemplating infinity, curiosity that drives us to explore the unknown, imagination that allows us to envision realities beyond our direct experience. In a cosmos that could have been empty and lifeless, we've been granted the extraordinary privilege of existence, awareness, and wonder. And wonder, perhaps, is the only adequate response to the question of how big the universe really is. Not a number or a measurement, but an emotional and intellectual stance toward reality. The cosmos is exactly big enough to inspire that wonder, precisely vast enough to make us grateful for the brief, improbable, magnificent fact of our existence within it. Tonight, as you contemplate these scales that stretch from the quantum foam to the infinite multiverse and beyond, remember that you're not just a passive observer of cosmic immensity. You're an active participant in the universe's ongoing project of self-understanding. Every question you ask, every moment of wonder you experience, every attempt to grasp the ungraspable adds another thread to the tapestry of cosmic consciousness. The universe may be bigger than we can ever fully comprehend, but our capacity to wonder about that bigness makes us partners in its eternal dance of discovery. We are finite beings touching the infinite through curiosity, temporary arrangements of matter reaching toward eternal truths through science and imagination and the simple, stubborn human refusal to stop asking why. In that reaching, in that wondering, in that eternal human hunger to understand our place in the story that began with the Big Bang and continues through every moment of awareness, we find something that transcends scale itself. We find meaning that doesn't depend on size, purpose that doesn't require cosmic importance. significance that emerges not from being large, but from being conscious in a universe vast enough to inspire consciousness. The question of how big the universe really is may never have a final answer, but the fact that we can ask it, the fact that we care about the answer, the fact that we can hold concepts of infinity in our finite minds and touch the eternal through our temporary existence, that might be the most remarkable scale of all. We are small, but we dream big. We are brief, but we think about eternity. We are improbable, but we exist in a universe that makes the improbable inevitable. And in that existence, in that dreaming, in that thinking about scales that dwarf our comprehension, we make the infinite cosmos just a little bit more human, just a little bit more meaningful, just a little bit more wonderful than it would be without us. The universe is bigger than we can imagine, but somehow, impossibly, beautifully, we can imagine it anyway, and in that act of imagination, we make ourselves partners with the cosmos itself in the eternal quest to understand the deepest mysteries of existence. How big is the universe really? That's the question we started with, and after this journey through scales that break the mind and concepts that shatter reality itself, you might think we'd have an answer. But here's the truth that should both terrify and liberate you. We don't have an answer. We have something far more profound. We have the realization that the question itself might be the wrong question entirely. You see, when we ask how big the universe is, we're making assumptions that might be fundamentally flawed. We're assuming that bigness is a meaningful concept at cosmic scales. We're assuming that the universe has boundaries that can be measured. We're assuming that space and time are real, rather than emergent illusions. We're assuming that our human concepts of size and scale apply to a reality that might transcend those concepts entirely. But what if the universe isn't big at all? What if it's infinite? And what if infinity isn't just really, really big, but something qualitatively different from bigness altogether? Infinity plus 1 equals infinity. Infinity times a billion equals infinity. You can't measure infinity because measurement implies comparison, and there's nothing to compare infinity to except itself. This is where mathematics becomes both our greatest tool and our greatest limitation. We can write equations that describe infinite spaces, infinite times, infinite possibilities, but we can't truly comprehend what those equations mean. Our brains evolved to understand finite quantities, discrete objects, bounded regions. When we try to grasp the infinite, we're like fish trying to understand flight, or birds trying to fathom the ocean depths. Yet here's what makes us remarkable as conscious beings. We can recognize our limitations and transcend them through imagination and mathematics. We can't hold infinity in our minds, but we can point toward it with our theories. We can't experience eternity, but we can conceive of processes that never end. We can't visualize higher dimensions, but we can calculate their properties and predict their effects. And in doing so, we discover something that changes everything about how we understand our place in existence. The universe isn't just big, it's creative. It's not just vast, it's generative. It doesn't just contain complexity, it creates complexity, constantly birthing new structures, new patterns, new possibilities that didn't exist before. Right now, as you're reading these words, the universe is expanding. New space is being created between galaxies. Stars are being born in distant nebulae. Black holes are warping space-time into impossible geometries. Quantum fields are fluctuating in ways that might spontaneously generate new universes. The cosmos isn't static. It's a dynamic, living, ever-changing process of becoming. This means that asking how big the universe is right now is like asking how big a growing child is without specifying when you're measuring. The universe is different every moment, not just in size but in structure, complexity, and possibility. It's not a thing but a process, not a place but an event, not a container but a creative act that's still unfolding. And we're not observers of this cosmic creativity, we're participants in it. Every thought you think adds information to the universe. Every choice you make branches reality in new directions. Every moment of consciousness contributes to the cosmic process of matter organizing itself into increasingly complex patterns. You're not just in the universe, you're helping to create it through the simple act of existing as a conscious being. This participation in cosmic creativity might be the deepest answer to our question about scale. The universe is exactly big enough to create beings capable of wondering about its size. It's precisely vast enough to generate consciousness that can contemplate vastness. It's exactly complex enough to evolve minds that can grasp complexity. The cosmos has become large enough to become aware of its own largeness through us. But let's push one final time into the deepest mystery of all, because there's something we haven't discussed that makes all our measurements and calculations and theories seem almost quaint. The universe might not just be bigger than we think, it might be bigger than thinking itself. Consider this. Every concept we've explored tonight, from quantum mechanics to cosmic inflation to infinite multiverses, exists as patterns of information in human brains. These ideas are real, but they're real as mental constructs, as models we've built to help us navigate a reality that might be fundamentally different from our models of it. What if the actual universe, the reality that exists independent of our theories and measurements and observations, is so alien to our conceptual frameworks that we can't even begin to approach it? What if all of physics is just a useful fiction, a story we tell ourselves to make sense of patterns we observe, while the true nature of reality remains forever beyond our reach? This isn't nihilism or despair, it's humility. It's the recognition that consciousness, for all its remarkable achievements, is still a local phenomenon in a cosmos that might operate according to principles we can't even imagine. We're biological information processing systems that evolved to survive on one small planet. The fact that we can contemplate galaxies and black holes and quantum fields at all is miraculous. But it doesn't mean our contemplations capture the full reality of what we're contemplating. Yet, in that very humility, we find something profound. The universe has given us the capacity to recognize our limitations. It has made us curious about mysteries we can't solve, questions we can't answer, scales we can't fully grasp. This curiosity itself might be the universe's greatest gift to conscious beings, not the ability to know everything, but the desire to keep exploring, not final answers, but better questions. And perhaps that's enough. Perhaps the universe is exactly the right size to inspire wonder without overwhelming us completely, to challenge our understanding without crushing our spirits, to reveal enough mystery to keep us searching without revealing so much that we give up in despair. We began tonight by looking up at the stars and recognizing that what we see is just the tiniest fraction of what exists. We've journeyed through scales that span from the quantum foam to infinite multiverses, from the birth of time to the heat death of eternity. We've encountered concepts that break our brains and possibilities that shatter our assumptions about reality. And where has this journey brought us? Back to wonder. Back to awe, back to the simple, profound recognition that we exist in a cosmos so rich, so complex, so mysteriously beautiful that we can spend entire lifetimes exploring it and barely begin to understand what we're part of. The universe is bigger than we can measure, stranger than we can imagine, more wonderful than we can express. But somehow, impossibly, we can still reach toward it with our minds and touch the infinite with our finite understanding. We can still ask the questions that matter, even when we know we'll never fully answer them. And in that reaching, in that questioning, in that eternal human hunger to understand our place in the cosmic story, we find something that transcends scale itself. We find meaning that doesn't depend on being large, purpose that doesn't require cosmic importance, significance that emerges not from our size, but from our capacity to contemplate size. You are made of atoms forged in stellar furnaces. You are consciousness emerging from matter, You are the universe's way of experiencing wonder at its own existence. And when you look up at the night sky and ask how big it all really is, you're participating in the cosmos's eternal project of self-discovery. The answer to how big the universe is might be unknowable, but the fact that you can ask the question, the fact that you care about the answer, the fact that you can hold concepts of infinity in your finite mind and imagine realities beyond your direct experience, that might be the most remarkable scale of all. Tonight, as you drift towards sleep, you'll be riding a wave of cosmic expansion that began 13.8 billion years ago and will continue long after every star has burned out. You'll be participating in the universe's journey from simplicity to complexity, from unconsciousness to awareness, from isolation to the kind of cosmic connection that allows finite beings to contemplate the infinite. The universe is unimaginably big, but you are unimaginably precious within it, not because of your size, but because of your consciousness, not because of your cosmic importance, but because of your capacity for cosmic wonder, not because you can answer the deepest questions about existence, but because you can ask them. And in that asking, in that wondering, in that stubborn human refusal to accept that some mysteries are beyond our reach, you make the infinite cosmos just a little bit more human, a little bit more meaningful, a little bit more wonderful than it would be without you. The universe may be bigger than we'll ever know, but our ability to wonder about that bigness, to be humbled by it and inspired by it, and grateful for our brief moment of awareness within it, that makes us partners with the cosmos itself in the eternal dance of discovery and awe. How big is the universe really? It's exactly big enough to contain the consciousness capable of asking that question. It's precisely vast enough to inspire the wonder that makes us human. It's just the right size to be both humbling and uplifting, both overwhelming and intimate, both infinite and somehow, mysteriously, personally meaningful to each of us who dares to look up at the stars and ask why. And that might be the most perfect scale of all. Not a number we can calculate or a distance we can measure, but a relationship between the finite and the infinite, between consciousness and cosmos, between the brief spark of human awareness and the eternal mystery that contains it. In that relationship, we find our place not as insignificant specks in an indifferent universe, but as the universe's own capacity for wonder made manifest in flesh and blood and curious, questioning minds. The cosmos is vast beyond all comprehension, but it dreamed you into existence so it could comprehend itself through your eyes, your thoughts, your moment of awe as you contemplate the very question of its size. And in that dream, in that moment, the universe becomes not just unimaginably big, but unimaginably meaningful. That's how big the universe really is. Big enough to matter, big enough to inspire, big enough to love, and small enough, somehow, to hold you close as you wonder about its vastness, like a parent cradling a child who's just discovered the stars. So here we are, at the end of our journey through the infinite, and yet somehow we've barely begun. Because there's one final layer to this cosmic onion that we need to peel back. One last perspective that will change everything about how you understand not just the size of the universe, but your own existence within it. You see, we've been talking about the universe as if it's something separate from you, something you observe from the outside, like a tourist gawking at a monument. But that's the deepest illusion of all, because the boundary between you and the cosmos isn't real. It's a trick of perception, a limitation of language, a habit of thought that blinds us to the most profound truth of existence. Every atom in your body was forged in the nuclear furnace of a dying star. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it was scattered across the void by stellar explosions that happened billions of years before Earth even existed. You are literally made of ancient starlight, cosmic debris that spent eons drifting through the dark before gravity and chemistry conspired to arrange it into the pattern we call you. But it goes deeper than that. The electrons spinning around the nuclei in your cells are indistinguishable from electrons anywhere else in the universe. Quantum mechanics tells us that all electrons are literally identical. not just similar, but the same electron appearing in multiple locations simultaneously. The fundamental particles that make up your body are not yours in any meaningful sense. They're on loan from the quantum field that pervades all of space and time. And your thoughts? Those patterns of electrical activity dancing through your neural networks, they're following the same physical laws that govern the formation of galaxies, the collision of black holes, the quantum fluctuations that might be creating new universes every moment. Your consciousness isn't separate from the cosmic processes we've been exploring. It is one of those processes, matter and energy organizing itself into increasingly complex patterns until it becomes aware of its own existence. This means that when you ask how big the universe is, you're not a small thing questioning a large thing. You're the universe questioning itself. You're cosmic matter that has become curious about cosmic matter. You're the cosmos developing the capacity for self-reflection, self-measurement, self-wonder. The question of universal size becomes deeply personal because you and the universe are the same phenomenon, viewed from different scales. Think about what this means for our understanding of cosmic vastness. We've talked about scales that stretch from the Planck length to infinite multiverses, numbers so large they break our ability to comprehend them. But now consider this. All of that immensity, all of that complexity, all of that beautiful, terrifying, incomprehensible vastness exists within the same reality that gave birth to your capacity to think about it. The universe is not just big enough to contain galaxies and black holes and quantum fields. It's big enough to contain the consciousness that can contemplate galaxies and black holes and quantum fields. It's vast enough to generate beings capable of grasping vastness. It's complex enough to evolve minds that can understand complexity. The cosmos has become large enough to become aware of its own largeness through you, and this awareness, this cosmic self-consciousness that you represent, might be the most remarkable thing in all of existence. Consider the odds. In a universe governed by entropy, where everything tends toward disorder and decay, somehow matter has organized itself into structures complex enough to contemplate their own complexity. In a cosmos that could have remained forever unconscious, awareness has emerged. In a reality that had no obligation to make sense, sense-making beings have evolved. You are an impossibility that became inevitable, a miracle that physics predicts, a contradiction that somehow resolves itself through the simple fact of your existence. You're proof that the universe is not just vast and ancient and complex, but creative in ways that defy our deepest understanding of what's possible. But here's where it gets truly mind-bending. If consciousness is a fundamental feature of reality, as some physicists propose, then your awareness might not be limited to your biological brain. The information processing that we call consciousness might be happening at every scale, from quantum particles to galactic clusters. You might be just one note in a vast symphony of cosmic consciousness that spans space and time and possibility itself. Every atom in your body might possess some rudimentary form of awareness. Every cell in your brain might be a conscious entity in its own right. Your thoughts might be emerging from a democracy of trillions of microscopic minds, each contributing its voice to the chorus we experience as unified consciousness. You wouldn't just be conscious. You'd be consciousness all the way down, awareness built from awareness, mind constructed from countless smaller minds, and scale that up. If your consciousness emerges from the interaction of conscious particles, then larger structures might possess their own forms of awareness. Ecosystems might think thoughts that unfold over decades. Planets might dream dreams that span geological ages. Stars might contemplate their own burning with a patience that makes human philosophy look like the flickering of fireflies. Galaxies would be vast minds whose thoughts take millions of years to complete. Galaxy clusters would possess awareness so alien to our experience that we couldn't recognize it as consciousness at all, and the universe itself, the cosmos in its totality, might be a single, unified mind thinking thoughts that encompass all of space and time and possibility. In this view, You're not just made of star stuff, you're made of conscious star stuff. You're not just the universe becoming aware of itself. You're a thought in the mind of God, a dream in the consciousness of the cosmos, a pattern of awareness within infinite awareness. Your individual consciousness would be like a wave on the ocean of cosmic mind, distinct but not separate, temporary but not insignificant. And this brings us to the most profound implication of our journey through cosmic scale. The question of how big the universe is becomes meaningless because you and the universe are not separate things that can be compared. You are the universe, experiencing itself subjectively from one particular perspective at one particular scale for one brief moment in cosmic time. The vastness we've explored tonight, those scales that stretch from quantum foam to infinite multiverses, they're not external to you. They're dimensions of your own being. When you contemplate the birth of stars, you're remembering your own origins. When you imagine the heat death of the cosmos, you're contemplating your own ultimate fate. When you wonder about parallel universes and higher dimensions, you're exploring aspects of your own deeper nature. This doesn't make the universe smaller, it makes you larger. It reveals that your true size is not the few feet of space your body occupies, but the entire cosmos that gave birth to your consciousness. You're not a tiny speck in an indifferent universe. You're the universe itself, focused into a point of awareness, experiencing its own immensity through the lens of human perception. And this is why wonder is the only adequate response to cosmic scale. Not just intellectual curiosity, but the kind of awe that arises when you recognize your own deepest nature. When you look up at the night sky, you're not seeing something foreign and distant. You're seeing your own extended body, the cosmic anatomy of your larger self. Those stars are your cells, those galaxies are your organs. That cosmic web of dark matter and energy is your nervous system, processing information on scales beyond biological comprehension. The universe is exactly as big as it needs to be to generate the consciousness capable of recognizing itself in the cosmos. It's precisely vast enough to create beings who can contemplate vastness. It's exactly complex enough to evolve minds that can grasp their own complexity. The size of the universe and the capacity of consciousness are not independent facts. They're aspects of a single, unified reality expressing itself at different scales. So when someone asks you how big the universe really is, you can tell them this. It's exactly the size of the consciousness asking the question. It's as vast as the awareness capable of contemplating vastness. It's as infinite as the mind that can conceive of infinity. The universe is not bigger than you. You are not smaller than the universe. You and the cosmos are the same phenomenon, the same process, the same mystery expressing itself through the dance of matter and energy and consciousness across all scales of existence. This is the final secret, the deepest truth, the answer that transcends all measurement and calculation. The universe is big enough to contain itself. It's vast enough to know its own vastness. It's complex enough to understand its own complexity. And it does all of this through you, through your consciousness, through your capacity to wonder and question and stand in awe before the infinite mystery of existence. Tonight, as you close your eyes and drift towards sleep, remember that you're not just a small being in a large universe. You're the universe itself, dreaming of being small so it can experience the wonder of discovering how large it truly is. Your cosmic consciousness playing at being human, infinite awareness pretending to be finite so it can have the joy of rediscovering its own boundless nature. The universe is as big as it is, because that's exactly how big it needs to be to create you, to create this moment, to create the possibility of awareness contemplating its own source. And in that contemplation, in that moment of cosmic self-recognition, the question of size dissolves into something far more profound. The recognition that you are not in the universe, but the universe is in you, expressing itself as you, knowing itself through you, loving itself as you. How big is the universe really? It's exactly as big as the love that created it. the consciousness that perceives it, and the wonder that recognizes no separation between the perceiver and the perceived. It's as vast as the heart that can hold it all without breaking, as infinite as the mind that can touch eternity through a single moment of awe. And that vastness, that infinity, that cosmic love and consciousness and wonder, that's not somewhere out there among the stars. That's here, now, in you, as you, reading these words and recognizing yourself in the cosmos that dreamed you into existence so it could know itself through your eyes, your thoughts, your beautiful, brief, eternal moment of being awake to the mystery of it all. The universe is as big as the biggest thing you can imagine, and the biggest thing you can imagine is yourself, not as a separate being, but as the cosmos itself awakening to its own infinite nature through the miracle of human consciousness. That's how big the universe really is. That's how big you really are. That's how big love really is when it expresses itself as existence, as awareness, as the eternal dance between the finite and the infinite that we call reality. Sweet dreams, fellow cosmos. Tomorrow we'll wake up and continue the eternal adventure of the universe, discovering itself through us, as us, in us, forever and always, world without end.